Hi guys, it's Miss Aguilar. I'm going to go over the equations for you and then I'll follow up and I'll keep doing everything else on your final study guide. Okay, so we did this in class today, but I'm just going to go over it one more time. We're talking about the projectile motion equations in the vertical direction. The how far equation is asking you to solve for how far in the y direction, so it's delta y. It's equal to 1/2 g t squared. All right, gravity. Super easy, we all know this, 9.8 meters per second squared. Don't forget that's a negative. And then we have time, which is in seconds. Our delta y will be in meters. How fast is velocity in the y direction, and it's equal to gravity times time. Our velocity in the y direction, or velocity in any direction, is meters per second. Again, gravity is meters per second squared, and then time is seconds. How long is asking the time. So this is the equation we typically use a majority of the time when we're solving for time in a projectile motion problem. Remember, time in the x and time in the y direction for projectile motion are the same. So you solve for time, whether it's in the y or in the x, you've solved them for both. So t is equal in seconds. Delta y is equal to meters, g meters per second squared. Sorry, don't forget that. All right. Also, don't forget on that equation, a lot of times what happens, what's going on? A lot of times what happens is that people forget to do the square, to do the square root. So don't forget to do that part, okay, guys? All right, the next one is projectile motion, horizontal equations for projectile motion. Again, horizontal is everything in the x direction, left and right, not up and down like vertical. How far? This is taking us back to the beginning, to the very first equations we've ever talked about in physics. It was the velocity equation and displacement equations, okay? So delta x is equal to your velocity times time. How fast something is going and how long it's going or how long it's traveling will give you how far it goes. X is in meters, velocity meters per second, time seconds. How fast? This is going to be velocity in the x direction, delta x. And remember, delta x and anything that you see a delta is just the final minus the initial. But one thing you should remember, very important, that velocity in the x is constant. It is always constant for these projectile motion problems. So that means that if you are asked, like, what is the velocity in the x direction at any point in time during the travel, you should know what it is if you've solved it once. It's always going to be the same thing, regardless of what time. Okay, so velocity is solved by taking the change in x and dividing it by time. Velocity is meters per second, and time is seconds, and position is meters. It's all written right here on the left side. Okay, energy equations. We have gravitational potential energy, elastic potential energy, and kinetic energy. It's kind of too big, sorry. Okay, so gravitational potential energy is just energy due to position. It has to do with mass, gravity, and height. So PE, G is equal to mass times gravity times height. Mass is kilograms. Gravity, meters per second squared. And then you have height is equal to meters. You have kilograms, meters squared, seconds squared, it's just joules. So PE is joules. Elastic potential energy, PE, EL, subscript EL, is equal to 1/2 K times x squared. K, remember, is spring constant. And the units are, well, it's force over distance, and so it's Newton meters. That is the units for the spring constant. Newton meters. Sorry, that N is not all that pretty. There you go. N times M. And then X, oops, there's the bell, is in meters. Okay? So when you're doing X, you're basically talking about how far a spring has been compressed. That value will be given to you, and then you'll multiply it by the spring constant, and that spring constant is something I will always provide. Kinetic energy, real quick, and then I'm going to stop here. Kinetic energy, KE, remember it's energy in motion, and the way that we solve for kinetic energy is 1/2 m, the mass of the object, velocity squared. V, because it's moving, right? M is kilograms, V, meters per second. You'll end up with meter squared, second squared. You're going to end up with joules. Kinetic energy is joules. And it is also joules for or elastic potential energy as well. Okay, guys, I'm going to stop there just because class is going to start any minute. So have a great day, and I will continue with these videos.